Rotation, you guys know it just means like turning something around a point. So there has to be a point that you rotate around, kind of like a clock, like the middle of a clock kind of thing. So if I rotated this like 90 degrees clockwise, how far would that be and in what direction? Well, you guys know how to figure out clockwise and counterclockwise?
Clockwise, right?
Yeah, you just kind of use a clock, right? This clock is moving clockwise. So at the top, it's to the right, but at the bottom, it's going to the left, actually. So, yeah, and then counterclockwise is going the opposite direction. If you're like trying to, let's say, put a lid on, is that clockwise or counterclockwise? That's clockwise. Or take it off is counterclockwise. If you're trying to put a screw in the wall, that would be clockwise. Take it out, it's counterclockwise. You could design them to be opposite, but everybody does the same thing. So, yeah, so if I wanted to rotate this 90 degrees clockwise, what would it look like? Well, if this is my center, how much of a turn is 90 degrees? It's like a quarter of a turn, right? So a full circle is 360, like a full rotation is 360 degrees. And a half a rotation would be like 180 degrees. So 90 degrees is only 1/4 of a rotation, so it would look something like this, like it would move this line down here and this line like over here. Anyways, it would look like that. That's our point of rotation. Just kind of turns it around like that. That would be 90 degrees clockwise. And 90 degrees counterclockwise looks something like that. Rotate 90 degrees to the left. So yeah, it's turning around a point. What does reflection mean? Yeah, the alternate definition is flip. So on a reflection, you need something to reflect, and then you need a line of reflection, like which direction are you going? So you just flip it over that line like a pancake, and you don't have to do this stuff on an XY graph, but we are going to be using XY coordinate plane graphing to help us like get it nice and neat. So yeah, it's like a flip. So notice the point that's farthest away from the line maps to this point that's farthest away from the line. And the close point is close, and the close point is close. Okay, so if this rotation means turn, reflection means flip, what's translation mean? This might be the weirdest one. Easiest to do, weirdest term. Anybody want to guess? Sometimes in algebra, we did problems like I don't know if you guys remember this. You guys remember what shape this x squared graphs are?
U.
Yeah, parabolas, yes, kind of a U shape. And what's this -2 and +1 do to the graph? Right 2, up 1, yeah. Yeah, right to it. We didn't do that this year, did we? Not in geometry?
Last year.
Yeah, that's last year. I didn't think we did anything in geometry like that. Yeah, moves the graph right 2 and right up 1. So the book would always say, describe the translations of this graph. Okay, so what they meant was, how does it move? So a translation, the simple term is, it's a slide. And that's what we're doing today, because today's Wednesday, so I did the easy one today. So it doesn't flip or rotate or anything, it just, moves down, or whatever direction it goes. Okay, it just shifts over. All right.
That's not singing, that's just saying the lyrics in a very methodical way. Your singing is like this.
And these
The
are
difference-
professionals.
The difference is, I sound good.
Yeah, let's go.
I don't normally sing, it's her. I sound wonderful.
No, you
No,
don't.
you
I
don't.
do.
You just
I
sound
even
so
sound better, and I
bad,
don't do
bro.
it as a passion. I do it as a,
Fake it so you
I do it as a drug. Singing
Bro,
is my drug.
imagine if you said when I'm like American Idol,
Yeah.
because Simon Cowell was like Simon Cowell was like a reporter.
One day we're gonna be old and in a retirement home, and they're just gonna start singing. And they're just gonna like turn off their oxygen. So they can't. They just can't.
Okay, so on number 1, this page is backwards. Oh, that's the answer sheet. You guys don't need the answer sheet, these are easy. We're supposed to translate it one to the left. Let me go to the graph paper here.
And someone, or Allison has it now. She has it on her pencil.
I had the H in my bag.
Looks like the Humpback of Notre Dame.
Okay.
It's this shirt.
I'm not gonna do all these, I'm just gonna do one as an example, but, looks like that, right? So, when you draw the translation, so all you do is you look at every point that's like every vertex on the graph and just slide it one to the left. And this new point where it ends up is called, if this is called x, this is called x prime. Okay, if this is g, this is g prime. Q, q prime. U, u prime. And you know, you just connect the dots.
Oh, is that always the pivot one?
Hmm?
No, it just says
No,
to.
that was what the direction was.
Oh, that's just what number 1 says. Number 2 says 1 right, 2 down. So, like, yeah, just use each vertex, like T moves right 1, down 2, put a dot. E moves right 1, down 2, put a dot. I moves right 1, down 2, put a dot. And then just connect the dots. You got T prime. 5 and 6, it's the same thing, they just didn't draw the first one for you. They just told you what points to use. So you have to draw UML yourself, triangle UML yourself, and then go 5 units up. Oh, so much work. Oh my. Okay, number 7 on the back. Says translate 2 units left and 1 unit down. Okay, we don't have to draw these, but if I were to move Q 2 units to the left, and Q is at 0, -1, if I moved it 2 left and 1 down, how would that affect, like, where is Q prime gonna be? Okay, to the left does what to the point? It changes the x value, right? It makes it go down 2. Okay, if you're moving 2 to the left, that means your x value is going to go down 2. So, you just have to minus 2 for the x value. If you're moving 1 down, what does that do to the point? What does
Also,
it changes the y value by making it go lower. Like if the y value was 0, it'll become -1. If the y value is -1, it'll become -2. So it makes the y value go down 1. To the left makes the x value go down 2, to the 1 down makes the y value go down 1. So you just have to subtract on number 7, all 4 of those points. You need to do -2 for the x value, -1 for the y value. On number 9, what would we do at those points?
Add and add.
Okay, 4 to the left would do what? That would be a -4 on the x value. 4 units up would do what to the point? If you're going up, what value does that change? The y value.
yeah.
By making Positive or negative?
Yeah.
Positive. Are you guys getting this?
Yeah,
Okay, it's not supposed to be a trick question. Number 11. Now, this does look easy, and it is easy. What do you think they mean by write a rule to describe the transformation?
How far it moves.
Yeah, describe its movement, like up tree, right to. It is kind of easy, but there is a way to get it wrong. Kind of easy too. For example, on 11, you might say it's down 4, and you would be wrong.
That's up.
so down 5.
That's the prime thing.
Yeah. If you look at, I don't see it on Q, but if you look at the U,
Oh, assuming the y-axis covers it.
yeah, it might be on the Y. Well, I don't know if they typed it. But if you look at the U prime is actually on the top. That means U, the lower U, is the starting point. So instead of, it's not actually moving down 4, it's actually moving up 4. So that's all you have to put on 11. Alright, that's it. Kinda easy peasy. Now I say that, you could still make mistakes though, so be careful.